Good morning, student. Let's start today's class. Today we are going to study about statical time division multiplexing. Okay. In previous classes we have studied about synchronous time division multiplexing. Okay. There is a there is some disadvantages in that synchronous time division multiplexing, so that we to recover from that disadvantages we use statical time division multiplexing. Okay. And what is that disadvantages of synchronous time division multiplexing? Let us see. Okay. As in synchronous time division, each input has a reserved slot in the output frame. Okay. you know in synchronous time division multiplexing, what happened? There is how much or there is how many inputs are there. Okay. If there is 4 inputs, okay, so that there is 4 time slot reserved for that 4 inputs. Okay. For each inputs there is 1 time slot reserved. Okay. But that reserved or reservation process, or the reservation of time slot is the disadvantages. Okay. Because if you think that if one there is 4 input. Okay. But 3 input want to send data, but the fourth input is not want to, or the fourth input is not wanting to send data, or the fourth input is let's say ideal. Okay. That no, he don't want to send data. So uh, the output slot, or the out in the output side, uh, the time slot which is reserved for fourth one is unnecessary. Okay. That is not efficient. Okay. so to reduce that unnecessary reserved time slot, we use statical time division multiplexing. Okay. Because in statical time division multiplexing, slots are dynamically allocated to improve bandwidth efficiency. Okay. Here what happened, in statical TDM, okay, or time division multiplexing, the time slot booked dynamically means kono, uh, let's say that for input 1, okay, want to send data, so one time slot is reserved for input 1. Then let's say input 2 don't want to send any data. Okay. Rest in a ideal Want to rest in a ideal state. Okay. So that the time slot booked or reserved for time 2, or sorry, input 2 is revoked or removed. Okay. And that slot is provided to another input which input want to send data. Okay. That is called dynamical. That means it is scan every time or round by round. Okay. Then um, which input want to send data, allocate times one time slot to that input. Okay. And which input didn't want to send any data, they uh, revoked or dismissed their time slot. Okay. Only when an input line has a slot worth of data to send, okay, is it given a slot in the output frame. This is called dynamic allocation of data. Sorry, time slot. Okay. In statical multiplexer, okay, the number of slot in each frame, okay, is less than the number of input line. Okay. It is obvious because the in because the number of input is let's say 4, but uh, that is not mandatory that all inputs should send data, okay, so that the number of inputs is higher than the number of slots allocation, okay, because if there is four number of inputs available, but three numbers of input want to send data, then only three slots should be booked or allocated for that three inputs, okay, so that the number of the in statical multiplexing, the number of state in each frame, okay, is less than the number of input lines, okay. The multiplexer checked each input, okay, in a round round robin, okay, fashion. Round robin, here you see the round robin, okay. What do you mean by round robin? Round robin means it will check input 1, then input 2, then input 3, then input 4, then input 5, then again it check input 1, input 2, input 3, input 4, input 5, then again this round and round checking is called round robin method, okay, round robin fashion, okay, so that in each um, checking, okay, it check whether the input is want to send data or not, okay. If that input is want to send data, then it allocate one time slot for them, otherwise it didn't allot any that time slot, okay, or data sorry time slot, okay, otherwise it skips the line and check the next line, okay. Now you see the difference between synchronous and uh, statical time division multiplexing, okay. You see here, this is synchronous time division multiplexing, this one, and this is statical time division multiplexing, okay. Then you see in synchronous, okay, in synchronous what happened, that let's say this is line A, line B, line C, line D, line D. There is 5 inputs, okay. So in 5 inputs the time slots are there, okay. In previous classes, this is the time slot, one time slot, okay, sorry, this is one time slot, okay, this is one time slot, and this one also one time slot, but here the time slot not allocated, okay. So if this uh, uh, first input A want to send only A1, okay, input B, B1 B1, B2 B1, input C didn't want any and send to any data, okay, D D2 D1, E E2, okay. So the frame which is built in output, okay, output side, be like what, this is the frame, 1 minute, this is the frame, okay, 0, then E1, sorry, then E2, from this to this E2, D2, then there is one gap, okay, this gap is disadvantages, okay. Then B2, then another gap, okay. So here you see in one frame there is two time slot or two unnecessary time slot, okay. Here also in frame 1 you see there is one, okay, there is two unnecessary time slot, okay. So that for the for this unnecessary time slot the bandwidth of the channel is used unnecessarily, okay. Because if we uh, don't allocate the vacant time, then we want or we used less bandwidth of channel. We use the cost of the channel is less. Okay, similar in the next process, or in the statical dynamic, or sorry, statical TDMA, we the frame is here. You see the frame. This is E, then E2. Okay, this is D, this is address. Okay, E and D is address. Okay, then D2, then B. You see, 1 minute. Let me zoom. Okay, you see, this is E. Okay, this is address, and this is data. Okay, then this is also address, this is data, then this is also address, this is data. Okay, and this is also address, this is data. There is no vacant uh, frame. Okay, or time slot. So here the uh, there is no unnecessary use of bandwidth. Okay, and you see, you notice that we use here addresses. Okay, this is called addresses. Okay, because here what happened, you see, why we need address in statical TDMA, but we don't need it in synchronous TDMA. Because you see, there is a in synchronous TDMA, what is there is a fixed pattern. Okay, that means fixed pattern means in output, or in mocks, we send, let's say, first input 1. Okay, then input 2, then input 3, then input 4. Okay, 1 2 3 4 data. Okay, so the receiver also known that the frame consists starting from input 1, then input 2, then input 3, then input 4. So there is a fixed pattern or predefined pattern are there. So, and the synchronous process are there, synchronous time slots are there, so that there is no error occur or no misunderstanding occur. Okay, fixed, that means uh, we send. Okay, here we send, here you see, we send first line E, then line D, then line C, which is vacant, then line B, then line A, which is vacant. This is fixed. So the output or the demux or demultiplexer known that first line E coming, then first line, then line D coming, then line C, then line B, then line A. Okay, so it denote as first one is line E, next second one line D, third one is line C, fourth one is line B, fifth one is line A. In that manner, it will decode. Okay, so there is no need of address. Okay, but in TDMA there is no such predefined mm, patterns, because in TDMA there is no gap. Okay, so after E, if here you see, after D, okay, this D, after there is no C. Okay, direct there is B. If we don't use address, then the uh, decoder or output side understood that this data. Okay, if we don't use this address, this B2 is for C line C. Okay, and there is misunderstanding are there. Okay, so there is no fixed pattern in the statical TDMA, so we use address. From that address, the receiver understood that data is for E, and this address is the destination address. You should remember that this address is not the input address. Okay, this is the destination address. That means this data is going to the destination address E. Okay, the output address E. Okay, Next, addressing. Addressing, I told you. Then the time size or slot size. Okay, even the since it is static, since it is statical TDMA, a slot carries both data and an address. Okay, the ratio of data size to the address size must be reasonable to make transmission efficient for a efficient. That means here data slot one because one data here in a statical TDMA, one data need one address. Okay, that data or one data or two data is needing one address. Okay, so the ratio of time slot the ratio of the data size to the address size must be reasonable. Means there is, if there is one address size or address size, there is two or three data size should be there. Okay, so there is reasonable ratio of data and uh, address size. Okay, or the ratio of data size and address size. Okay, next, the in statical TDM bandwidth, in statical TDMA, the capacity of this of the link is normally less than the sum of the capacity of the each channel. Okay, that means in statical TDMA, what happened, the channel, the capacity of the link, this link by through which the data will transmitted, all the data will transmitted. Okay, that bandwidth, okay, this bandwidth is always less than or normally less than the sum of all the inputs or channels capacity. Okay, because there is no vacant of time slot. Okay, and there is there should be some input which is not sending data. Okay, then there is, if there is four inputs, then let's say three input sending data, so three capacity of three inputs is always greater than the channel bandwidth. Okay, that's all. Thank you.